In this lesson, we're going to learn how to draw a pendulum system and a double pendulum system. Now this lesson will actually start with a task. And that task is quite simple. Drawing on all of your knowledge from previous lessons about the bouncing ball, draw this pendulum system. On screen you can see the two extreme keyframes of this pendulum system. On the left is keyframe number 1. That's the start point. On the right is the highest endpoint of the pendulum, and that will be on frame number 7. So what I want you to do is draw 7 frames of the pendulum swing. And those 7 frames will represent the forward, and then you can reverse them for the backward swing of the pendulum. And so just 7 frames will get you the entire animation for this first pendulum swing. Now remember, in any system where you're going to create these frames, you want to look at things like, is the ball, or the pendulum in this case, going to be moving constantly? Is it going to ease in? Is it going to ease out? In other words, is it going to accelerate? Is it going to decelerate? Or does the whole system move constantly? And the things that might change whether or not that happens is gravity, for example. Gravity will act on something and it will accelerate it. Or it might decelerate it if the thing is going up. So when you approach the system, consider all of those ideas. Now the first step to consider whether or not you have drawn your system accurately is to look at whether or not you've actually got your start and your end points correctly. When you start, if there is no friction to this system, this angle here should be the same as this angle here, because this ball will swing all the way up, and if there's no such thing as friction and there's no energy lost, it should end up in exactly the same place as it started at. Now the next thing to consider is where you've actually drawn the path of the pendulum. So a common mistake is to draw the path directly across, imagining that the ball or the pendulum will swing from here across to here. And these might be the position in each frame. But the problem with doing that is that the pendulum itself is incompressible, which means that it always stays the same length. And that means that it actually travels on an arc. Now I've chosen 7 frames very specifically because you can actually divide up the frame count to have a single frame in the middle. So frame 4 should appear right in the middle, and then you can divide all the rest of your frames equally across each side. But let's now check whether I've drawn this correctly, because just from eyeballing it, this looks like it's pretty good. The left and the right seem like they're pretty good start and stop points for my pendulum. Okay, and so now I've drawn a straight line down to my pendulum, to my middle frame of my pendulum, and you'll see there's a bit of a surprise here. This system is now not correct. I have not built this very well. And there's a couple of reasons why. The first is that I have not built the pendulum at equal lengths. So that's the first real problem, is that you need to be accurate with the lengths of your pendulum when you create this. You cannot just eyeball it like in every other thing we do with animation. You have to be accurate. So in eyeballing the length of the pendulum, I've now messed up the nature of this animation. And the other thing should be quite obvious when you're looking at the angles between the middle and the edge here. These two angles are very different, and they should not be. They should be equal if we're assuming a system has no friction. And so we need to fix that before we can actually go on and make a proper pendulum system. So here we have our fixed system. And if you look at the position of the original ball, you can see how much of a problem we were creating for ourselves. This now is a properly aligned system where the angles here and here are equal. And that means now that when we create our middle pendulum ball, our main keyframe in the middle, it will now split these pendulums. And so you can see that if I'd drawn my arc of the pendulum to be something like that, This now shows the right type of swing for a pendulum. So what I would have hoped to see is a keyframe system that looked a little something like this. And you can see that there is a symmetry to how this is working. The pendulum will accelerate as it goes away from its initial position, drawn down by gravity, until it hits this lowest point, at which point it will swing through and gravity will start acting against it. And so the action will get slower and slower, or the velocity of the pendulum will get slower and slower as gravity pulls it back, until it hits its highest point, at which point gravity will again start pulling it back and the system will repeat. If you had taken the time to draw each ball, then I would have hoped for something that looked a bit like this. So that is the first and most basic task of this lesson, is to create this pendulum system. But the next task is to create the same pendulum system, but this time running on 4 frames. And that is to say, you're starting with the same system that you've created, but this time you only need 4 frames in between, with all of the same rules and all of the same things you have to consider. Now, once you're done, again, the pendulum system will have movement that's defined by an arc. And this time, frame 1 will be here, let's say, frame 2, frame 3, and frame 4. Now, in 4 frames, you don't get to give much sense of acceleration and deceleration, but that's not really the point of this exercise. So once you've got this drawn, our next step is to go and become much more complex about how this system is going to work. So our next task is to take, instead of having one pendulum that moves by itself, we're going to have a dual pendulum system. And this pendulum is going to swing backwards and forwards. And so just like our original, this pendulum is going to swing backwards and forwards. It's going to swing backwards and forwards on our original 7 frames, which means that it'll start here, and then 7 frames later, it's going to be up here, and then it'll swing back 7 frames later. So it's just swinging backwards and forwards. Every 7 frames, it's moved one part of that revolution. Now, our bottom pendulum is going to be doing the same thing. It's going to be swinging backwards and forwards. But importantly, it will be swinging backwards and forwards on 4 frames while attached to the parent pendulum swinging backwards and forwards on 7 frames. And this is where your understanding of timing and spacing becomes absolutely vital, because these 2 systems are linked together, but they're working on completely different timings. So the only way you can get this to work is to be very precise about how all of this works. Now, when you come to create this dual pendulum system, there are no restrictions as to whether or not the parent or the child pendulum is any longer or shorter than each other. And there's no restriction as to whether or not the pendulum moves at exactly the same distances. So, for example, you might see the top pendulum up here might swing through this way, which is exactly the same distance as the child pendulum. That's totally okay. The key point here is that the parent pendulum swings in 7 frames and the child swings in 4. And what that means is, as they swing, they will become desynchronized in their swinging. And that means you need to think very carefully about how it is that you actually position the child pendulum relative to the parent pendulum. Now, one of the things you'll notice is that the top pendulum has a horizontal line which it is attached to and swings off. Now, the child pendulum doesn't have this. It is attached to the parent, but there is still a conceptual line that you can see here. This line, when we actually animate, won't exist, but it helps us understand the rotational space of the parent. It helps us understand what direction the parent actually has rotated to. So this line here, which is horizontal in this example, is actually always 90 degrees to the main bar of the pendulum. So as the pendulum swings up to its highest point, this line that was horizontal is now 90 degrees to that main bar. And it's the same as it swings in the other direction. It gets a little cluttered, but you can see that this line remains 90 degrees to that one, to the main bar of the pendulum. And that allows us to understand the potential positions of our child pendulum, because the child pendulum is always swinging with the same angle to this horizontal line, or to this guideline. Now this might be quite difficult to follow the first time you start, but give it an attempt. You can see on screen the start position for the parent and the child pendulums. Follow this through, remembering that the guidelines are not visible for the parent-child, but they're there to help you as you move along the animation. Once you've given this an attempt, we will go through a potential way to approach solving this problem. So here is our parent pendulum at its highest point, and below that we see all the potential options for the child pendulum, bearing in mind that the child has 4 potential swings because it swings backwards and forwards every 4 frames. Now we know when we start that the pendulum will be at its highest point, and so will the child pendulum. But of course, as this swings further and further as we go, the child will become desynchronized. But to start with, we know that these 2 points are our highest point. So this becomes our starting position. And in the next frame, again we have all of these options, and this is now frame number 2. Now in this system they're still reasonably synchronized. So this is now our second position. In our third position, the ball is now swung 3 frames forward, and we can see that this now becomes our ball of interest. Now by the middle frame of the parent, we have now reached the high point of our child. And now this is where the system starts to desynchronize, because by frame 4, we've reached the end point for the first swing of the child, but the parent is still mid-swing. So now we're in frame number 5 of the parent swing. And for the child, we have now moved through 1, 2, 3, and 4, and now we need to come back. And this is no longer frame 3, this is frame 5. And hopefully you can see that as the parent pendulum swings, this perpendicular guideline that we are using provides an anchor for us to work out where to position the child's rotation as it swings through its own animation. Now, as we reach our high point for the parent, the child has gone through a full cycle of swinging up and back. So it has now gone from frame 1 to 2 to 3 to 4 to 5 to 6, and number 1 has now become frame number 7. And so you can see how understanding exactly your timings and your spacings becomes vital as this system moves on. Because when you start to build complex systems, you'll find them all interlinked. So while we've been calling this a double pendulum, this could just as easily be described as an arm that is swinging backwards and forwards. This is an example of what's called a forward kinematic system. The word kinematics simply means a way of describing how an object might move. A forward kinematic system is a parent-driven system. The parent drives the motion, and the child has to follow. But the child can move independently without the actual parent's input. And while these ideas are not necessary in order to draw a double pendulum, these are concepts that you will encounter as you start to animate more and more complex objects.